right, what I'm going to do in this one video here is I'm going to do one of the problems that we have in our optimization in our textbook for Calculus 1. And this first one is number 9 on page 306. And on number 9, this is the situation. It says, consider the following problem. A farmer with 700 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? So this is what we're going to do is we're going to set this up. I drew the picture, so they said a rectangular shape, so that's why I have the big rectangle here. And then one of the things I want you to notice that I did was, because it's rectangular, I know that this side and this sides are opposite and they're parallel, and they're opposite, congruent, and parallel. Sorry about that. And so what I did was I called this one whole side X, so I know this one's going to be X the same. And I took this rectangular area and just drew these lines, and they said they're parallel to that side to do 4 pens. And then I labeled those all Y. Because if I'm going to do fencing, I'm going to do fencing all the way around all of them, if you get my gist. So it's going to be all around everything. I'm just going to kind of show you how that would look all the way around everything. So when I go to set this up, we're going to still do the same thing we've always done, is we're going to organize it into constraint and objective. And our constraint and objective just help us think about what we're going to do. So here's my constraint. The constraint of the problem is what they told us that we need to have. And they told us that we had 700 feet of fencing. Okay. Well, 700 feet of fencing, if I look all the way around here, I forgot this side, is basically kind of the perimeter of that rectangle plus all the fencing here in between. And because I labeled it with X's and Y's, you could use L's and W's, A's and B's, it doesn't really matter, that I know that if I had 2 X's plus 1, 2, 3, 4, 5 of the Y's, I know that has to equal 750. So my constraint basically is the fencing. I have to have 700 feet of fencing, okay? Now, my objective, what they want us to find, is basically find the largest possible total area of all 4 pens. So basically, we're looking for the maximum area, okay? And I know the area of a rectangle, so I'm going to put it here. Area of a rectangle is base times height, or length times width, and according to my picture, it's X times Y. Okay, so I've basically come up with the fencing equation and the area equation, right? So now what I'm going to do is go through and solve for one of the variables. You could solve for X, you could solve for Y, it doesn't matter, but solve for one of the variables. And I actually solve for Y just because I guess we're used to it. So I have 5Y equals 250 minus 2X, 750 minus 2X. Then I'm going to go through and divide through by 5, and 750 divided by 5 is 150, minus 2 divided by 5 is 2/5 X. All right, that's my Y. What I'm going to do is, because that's my constraint, I'm going to take this right here, I'm going to circle it in yellow here, and I'm going to go and put it right here in this Y spot so I can find the max area with the constraint in it, because he only has 750 feet of fencing. So what we end up getting here is an area equation in one variable now. So it's 150 minus 2/5 X, okay? Now I'm going to go through and distribute that X, so I have 150X minus 2/5 X squared. And this is where people go, okay, I get this part, I don't know what to do next. Well, if we have been doing for extreme values and graphing, is remember when you look for maximum or minimum anything, we always did the first derivative and put it equal to 0, because that's where you find your turning points or your max and mins. So I basically here have to do the derivative of my area. So I'm going to change the color here because I want to make sure that you recognize I'm going to do A prime. And when I do A prime, I get 150, because it's the power rule, minus 4/5 X. Okay, now that's my F prime. Now I'm going to put it equal to 0 and solve for X. This will tell us the X that will give us a maximum area, because we're comparing the X and the area. So I'm just going to solve for this. So I have 4/5 x. I just moved this over to this side equals 150. You can divide by 4/5 or multiply by 5/4. And when you do, you get x comes out to be 187.5, and it's feet. We're talking feet. So I'm just going to do this. Now, before you go any further, so step one is I found the constraint, what they told you had to have. Step two is I set up the objective, like what we need to have. I then solve for a variable here, one of the variables, put it in this so that when I find my area equation right here, it's only in one variable. Then I'm going to do the derivative, which I showed here to tell us what is the maximum x we're going to need for the maximum area. I mean, what is the x we need for the maximum area? After you do this and say, I found x at 187.5 feet is going to give us the max area, you need to immediately do the first derivative test. So I'm going to set up my A prime bar. So I have 187.5 feet is what is I'm saying is a max. So this is my first derivative test. And we've been doing this, but since this is for your notes and for your homework, I want to make sure you know what you're doing. So this is what I'm doing here. You have to do this to check. So there's a couple ways to do that. What I would suggest is right here, when you have your A prime, this one right here, you're going to check, this is a number line really, to the left and to the right of this to see if we're going to get, if this is truly a max. So if I go to the left of 187.5, let's pick 100 because that's easy, all right? If I, right here, if I put 100 in here, 4/5 of 100 is 80. 150 minus 8, I have a positive number, so this is positive here. If I put anything higher, we'll say 200 here. If I stick a 200, 4/5 of 200, that's larger than 150, so this is a minus. So this is positive, negative. This truly is a maximum x. Okay, so I did my first derivative test. Now I'm going to continue on. Now that I know that, I'm going to figure out what y is, because I'm going to come back up here, is 150 minus 2/5 times 187.5. And when I do that, y comes out to be 75 feet. So now if I were to look at my picture here, right here, this is 187.5, and it is down here as well. And each of the y's are 75. Okay, they all add up to 750, and that's going to give us the maximum area. Okay, this looks a little messy. Maybe I'll put it down here because it's so close to this. It's 187.5 feet. And this is 75 feet. Now, we haven't really answered the question totally. They want to know what is that maximum area. So I'm going to do 187.5 feet times 75 feet, and just make sure that your units are correct. So the maximum area, the max area that that rectangle or that farmer can have is going to be 75 times 187.5. They're both in feet. So I'm going to get 14,062.50 square feet. 14,062.5 square feet. And that is the max area. So that is number 9 in our book, and I hope that helps you with our optimization.